This is something that is sort of experimental, but very difficult to do. So footprints. Footprints are very common at crime scenes. They're left almost all the time. You know, somebody steps in blood, they leave a print. Somebody steps in the dirt, they leave a print. The traditional way to analyze these is to take a photograph, again, at perpendicular to the surface. Well, this was something that I did. Oh, we have lots of snow in Canada, by the way. And here and here on the left is a photograph. And on the right here, what I've done is I've created a 3D scan of that print in snow, which is normally very difficult to do. You can see here there's all kinds of little details that come out of the footprint that you normally wouldn't get if you're just taking it in 2D. And I think what's most interesting about this is the equipment that I used to do this with was a digital camera. A digital camera and some software. So it's very inexpensive to do, relatively speaking to things like laser scanners and stuff, but the information you can get out of this is really, really important. On the analysis side, what I'm going to show you, most of what I'm going to show you now are areas of research that I'm doing with some students at University of Toronto, and I teach at a college called Humber College in Toronto, and there's a CSI program there, and I teach one of the courses there, but I have some students who help me do some of these things. This is the side of a bullet cartridge case, and what we've done is put a fingerprint on here, and on the right here is just a plain card fingerprint, just something on a flat card. And what I've done is I've used photogrammetry again by taking photos of an object that's relatively small, and I've created a 3D scan. So this is actually a movable surface that I can turn around and view from different angles. And the thinking here is that when you take a photograph of something like this, all the edges become highly distorted because of the perspective, right? They're wrapping around, they're getting further away from the camera, so there's some distortion there. So we want to get as much of a usable print as possible. So what I've done is I've taken this here, and just like a piece of paper, if you roll a piece of paper up into a tube, digitally I'm unwrapping it and unrolling it and making it flat again here. And then we're doing some analysis to see how much of a usable area now, or how much of the print have I lost or has been distorted relative to here. So it's sort of an interesting technique. And I should say that nowadays there are some new methods for developing fingerprints on cartridge cases years and years after the print was actually made. So bite mark analysis is an interesting one. Again, this is the traditional way to do something like this has been to take flat 2D images. But if I can get a cast of a person's dentition, and I can somehow get access to a photograph or even a 3D surface that has a bite mark on it, and I can scan the two, well, now I have two surfaces that are 3D. And when I put them together, I want to ask myself, how do I know they're the same? How do I know one left the mark, a mark or not? So there's some things like 3D deviation analysis that we can do to start looking at this. And again, this is experimental because there's not a lot of people doing this sort of thing. There's really no standards or no basis to say, well, this is what makes a match or what doesn't. But it's an interesting area. In a very similar fashion, footprints. So what I've done here is I've taken a scan of a boot, I've taken a scan of a print in sand, and I've put the two together digitally. And I said, okay, tell me all the areas, color all the areas that are within 0.1 millimeters or something like, or half a millimeter or something like this. And this is the kind of thing that you get out. And there's really not a lot of people doing anything like this in the world today. And I think it's very important to take all this 3D landscapes, 3D evidence, and start to reconstruct it in 3D. So I think this is a new and young and interesting forensic discipline, and I think in the future we're going to see a lot more of this, and hopefully one day maybe I'll be asking questions about CSI program, or I'll be on TV or something. Anyway, thank you.
Exactly in time.
Okay, did good.
You're a master.
I saw you creeping up from the side, so I said I better get that.
Thank you very much.
Thank you.